4.5 years ago, we had started off in this venture to develop our own technology to build our own antennas.
This particular project got started when we realized that there was a need for a new technology to accommodate the requirements of these very high frequency systems that our customers were starting to ask for.
We settled on using carbon fiber and composites because they've got a lot of benefits that sort of surpass metal. It's really the future of where antennas are going. From the initial design inception, we knew that we had to maintain very, very tight tolerances and tight surface accuracy on our panels, right from the initial casting all the way up to when we're actually installing them at site. So with that in mind, we try to implement checks and balances all the way along through our whole production process. So we use what's called vacuum infusion, and that's a process that basically allows us to lay up our dry preforms onto very tight tolerance molds and then inject resins into them, casting our net shape.
The opportunities available with the composite antenna are to create higher frequency communication systems for mobile communications.
Our customers are looking for solutions that allow them to access more available bandwidth in a larger contiguous space. Enter in V-band, Q-band, and those frequency ranges. Those frequency ranges have a lot of free available space to use, however, they're very technically challenging. At Calian SED, we take on those tough challenges that our customers have. We convert those tough challenges into real-world working solutions.
We started off placing 2 people out at the National Research Council for a year to do the technology transfer, and we made a conscious decision at the outset to grow the team from the ground up. We wanted a young team that would be aggressive, sharp, moving forward, a team that's clearly interested in the technology.
The testing that we performed at Guadalupe was critical to establishing this antenna technology as working not only from a mechanical point of view, but from an RF and system point of view. So the tests that we performed there did validate and verify that this antenna is a working, viable solution to Q and V band, which is very necessary for the industry right now.
As the temperature changes outside, or you go from winter to summertime, then we're not going to see nearly the impact on the performance of the antenna that would be seen by a metal reflector.
And as we go to higher and higher frequencies, that becomes very important because our surface accuracies need to be maintained. Thermal expansion is very, very low. So that works well because we have a wide variety of environments that we need to install into.
With carbon fiber composites becoming more and more common, the cost point was becoming attractive as well.
They're lightweight, rigid structure, easy to deploy, and when combined with inlaid de-icing, provide an excellent alternative to the steel structures that you see today. They also offer lower installation costs and much faster deployment.
We're fortunate here at SED that we've got such a breadth of capability that we're able to bring so many different amounts of expertise to the problem and solve each of them one at a time.